Regression modeling is a common model used in statistics to model data. There are different types of regression modeling, but one of the most common forms is linear regression modeling. This model is applied to data which might be considered to be linear. Let's start off by looking at an example. Here we have some data from a college physics lab. The data compares the voltage levels on a copper wire to the distance from a voltage source. 3 different trials were recorded using different ampere levels. This data was graphed in Excel. Here we can see that as amperes are increased, overall voltage levels increased. We can also see that as length increased, voltage levels decreased. Now we can apply the linear regression model found in Excel to our graph. This applies a linear equation to each of our 3 trials. Notice how each equation closely fits our data in the graph. This is an indication that this experiment is a good use of the linear regression model, and this model can be used to accurately predict the voltage levels at any point on the copper wire. Now we're going to transition into using linear regression modeling in computer networking. We're going to look at a study conducted in Beijing under IEEE. This study uses a 2-dimensional linear regression model to predict security attacks on a computer network. There are a variety of attacks that can occur on a network, and these include web attacks, DDoS attacks, random and non-random scanning worms. Each attack has a different outcome on the network, so it is important to model the survivability of any host on the network. Table 2 shows the data collected for the experiment. It takes in 2 parameters. The first parameter is the variability of the network host, which is the ratio of every type of host that survives at any point in time to the total number of survival hosts on the network. It also takes in a parameter called active IP, which is just the number of changeless IP addresses at any given moment of time on the network. From the data compiled, a 2-dimensional linear regression equation is determined. Using these regression analysis equations, HoneyNet Active attempts to predict attacks in the network system. During the trial represented by Figure 2, there are no attempts attacked on the network, but HoneyNet Active falsely predicted that there were attacks occurring. In Figure 3, actual attacks were carried out on the network. In this case, HoneyNet Active very accurately predicted these attacks. This leads to an important note about using HoneyNet Active model as a system to detect attacks on a computer network. The model is only accurate if the network is experiencing attacks. The HoneyNet Active model is a great example of how regression modeling can be an excellent tool to help engineers if all the correct parameters are met. Regression modeling, and any form of modeling in statistics, can be a very powerful tool to help engineers design better systems for the future. But it is crucial that they understand the limitations of their model in its given application in order to produce sound engineering results.